So I'm Ethan Tierkoff. I am an assistant professor in the Department of Geography, Environment, and Spatial Sciences. I'm a coastal geomorphologist.
Hi, everybody. My name is Erin Bunting. I'm an assistant professor in the Department of Geography, Environment, and Spatial Sciences. I'm also director of one of our groups on campus called Remote Sensing NGS Research and Outreach Services.
One of the things that I'm really focused on right now, trying to understand sort of what's happening along our Great Lakes shorelines in terms of coastal erosion, things like habitat loss and infrastructure damage. And a lot of these things are happening because we're at high lake levels and actually record high lake levels. And what that ends up doing is sort of putting the water's edge right in our backyards, right along where humans live. And so when we get storms and we get winter ice and all these kinds of things that are very common along our Great Lakes shorelines, the high water kind of exacerbates those processes. And so that's what I'm really interested in, is trying to unravel all these different processes and sort of players and drivers and things like that into, how the coast is changing, document that, and then figure out ways of being able to predict. My lab group uses a lot of drones. We use boats. We use sonar devices deployed from small boats. We use remotely controlled operated boats. We're trying to really understand at a particular area what processes are happening, and can we model that, and can we predict that? And that's great for getting some of the fundamental mechanics down, but that really doesn't give us a sense of, okay, how did this entire region respond to high lake level? And that's where some of the work that Dr. Bunting and I have been spearheading using citizen scientists becomes really important.
We are looking to engage citizens to fill a data gap to help coastal managers and researchers understand the vulnerability of the landscape. Like Ethan mentioned, like Dr. Tierkoff mentioned, lake level is at its highest point across many portions of the Great Lakes, and there's not data coverage to understand those processes and for us to build models to predict lake level changes into the future. So through the National Science Foundation, we have received this grant from the Coastlines and People Initiative to develop a comprehensive research and citizen science program. And my work in this is to build that citizen science part, to go out and to teach the community what it means to image their landscape and what we're using this data for. We're also doing research on the feasibility of such a citizen science program. Does it lead to people better understanding coastal hazards and landscape change across the Great Lakes? And that gives some idea for NSF about the feasibility of continuing such a project in the future. Additionally, what we're doing is we're looking at different coastal types across the Great Lakes, and we're seeing how are the patterns of landscape change varying over time, and what does that mean for the future? We can extrapolate out and understand some processes, and we can understand how humans are altering the landscape and either changing the rate of landscape conversion. So we've been working on this, like I said, for 2 years now, and it's a broad sweeping project that we're only hoping to grow into the future. And with that growth, what we're looking to do is expand beyond actually Michigan to the entire Great Lakes region, and to incorporate metrics of risk perceptions within communities and engage K-12 classrooms to understand about coastal hazards that are to learn from a young age what it means to value their coastlines and to understand the processes that are changing their coastlines.
So I think that's the really cool part about this thematic area, is we're sort of blending, some of these high resolution, process-based physical studies of the coast, how the coast responds to lake level and storms and ice and all these processes, but we're blending it with how do people either affect those processes, or how are they affected by those processes? And how can we sort of understand all of these coupled human natural systems to actually sort of affect the decision-making process and really get towards proactive decision-making?